Alright, we're going to be looking at graphing parabolas in vertex form. We're going to look at it in standard form, and this is going to be kind of a review of everything that we're going to learn about parabolas. Here is an equation of the parabola here in this graph, and it is in vertex form. And we call it vertex form because it actually gives us the vertex of this parabola. Now the vertex is either going to be the highest point or the lowest point. And because of the way this opens, the vertex is down here at the bottom. And if I was going to label that point, I would say, okay, starting from the middle, 1, 2, 3, 4, I went over 4 spaces, and I went down 2 spaces to get there, negative 2 because I went down. That is the vertex of this parabola. Now in vertex form, you are given those 2 numbers, but you'll notice that in the formula, in the equation in vertex form, the 4 looks like a negative because there's a negative in the formula for vertex form. And what I mean by that is, if you look at vertex form, you've got y equals a times x minus whatever that value is for the vertex, minus h squared plus k. Now the 2 in vertex form is a minus 2. It is going to be exactly what it looks like. It's going to be negative if it's negative in the formula. The only thing to look out for is that whatever this value is right here, when I take it out of the equation and make it a vertex, in the formula it looks like a minus 4. As in on the graph though, it's a positive 4. Now this negative 2 will stay exactly what it is, but just make sure when you take something from an equation in vertex form, if I were to ask you the vertex, what is the vertex, and I gave you the equation, just know that it changes signs when we're talking about the x value of the vertex, and that's because that equation already has a negative in it. That minus is actually in the equation. Alright, now I want to look at domain and range. Now if you remember when we talk about domain and range, the way that you can remember this, domain is an x, range is a y. They go in alphabetical order. X comes before y in the alphabet, just like domain, D comes before R in the alphabet. So it kind of helps you keep it straight which one we're talking about. Now if we're talking about domain of a parabola, and you see just a basic parabola, kind of like the one we have here, domain is an x value. Where is this graph going? We're talking about left to right here. Okay, so where's it going, left to right? A parabola, those arrows means that it goes forever to the left. Okay, and it's also going to the right forever. And the way that we describe left or right, or we use infinity symbols, left, if you look at the values of x as you move to the left, they're going to start getting negative. These values over here to the left, if I just keep going this direction forever, it's always going to be negative, so we would call that negative infinity. Okay, so when we're talking about domain, where is it going? Left is negative infinity, and to the right, those numbers are going to be positive forever. We'd call that positive infinity. Okay, so that's just how I would state the domain of a parabola. And you can also call that all real numbers. Okay, so if it includes every single x value, every single y value, we call that all real numbers. And there's a symbol for that you might see. It looks kind of like an R with 2 lines on it. That's the symbol for all real numbers. But if you're dealing with parabolas and it's asking for domain, it will almost every time, if it's just a basic parabola, it will always be all real numbers, or it'll be negative infinity to positive infinity. The only time that'll change is if there's a limit to the domain. Like for example, if you had a parabola and it didn't go forever, it might have a point where it starts here and it only goes to here and it stops, over here. That would be a domain that's restricted. It's limited to being between certain numbers. So if a domain does not go on and on forever, you would just describe that domain like, let's say that my graph went like exactly like this. Okay, we're talking about domain is always how wide is this graph. Okay, let's just look at this red kind of arc that I just drew right here. The domain is just how wide it is. So if you're looking at the x-axis, how wide is this? Well, stops here on the y-intercept at 0, and it goes all the way to 6. Okay, so I would use these little brackets here because it actually stops between those 2 points. Okay, so if it doesn't go forever, you're just talking about domain. How wide is that? What are the points that that graph includes? And that red arc there goes from 0 from left to right to 6. And that's how we would describe the domain. Now range is going to be basically up and down. How tall is it? What's its lowest point? What's its highest point? And this one has a lowest point. If you look over here on the bottom of the vertex, this is what we would call a minimum because it's the lowest point on the parabola. So it doesn't go down forever. And when we're talking about range is always the y-axis up and down. It goes up forever, but it only goes down to -2. It actually stops right here at -2. But if you're looking at this parabola, it goes up. Those arrows show that it's going up forever. Okay, so when we're talking about range, up is always going to be positive infinity. Down is always going to be negative infinity. So if I'm describing this, I'm going to say that it goes from -2, it goes up forever. So we call that positive infinity, and that's how I would represent the domain of this function. I mean the range of this function. Alright, now with parabolas, we're also going to be just labeling x-intercepts and y-intercepts, but with a parabola, a lot of times you're going to have more than one x-intercept, and another word for that is a root. Okay, they can call it the root, they can call it the solution. There's different things that they're going to call it, but it all means the same thing. So when we're looking for x-intercepts, we're just looking for where does this graph cross the x-axis, and this one crosses at a specific place. It actually crosses at the point where the x equals 3, and if I was given that as a point, I would say that's at the point 3, 0. Okay, it's always going to be, your x-intercept is always going to be at 0 on the y-axis. Okay, and the other x-intercept over here is at +5, so I'd say that's at 5, 0. Okay, those are my x-intercepts, and a lot of times they call those roots, or they may call those solutions, but just be aware that that's what that means. It's just asking for an x-intercept. Okay, now we talked about this vertex here being a minimum. Okay, you want to understand when you're dealing with a parabola. If it's upside down like this, it's a minimum. If you had a parabola that was opening the other direction, opening down like this, we would say that that highest point up here, the vertex, is actually the maximum. That's the highest that you can go. So it's either going to be a minimum or a maximum, depending on which way the parabola opens. If it opens down, it's going to have a maximum. If it opens up, it's going to have a lowest point, a minimum. That's all. That's a maximum is just a top. A minimum is just the bottom of that parabola. So just be aware of that when you're looking at parabolas and they ask you, does it have a minimum or a maximum? Does it have a top or a bottom? That's all that it's asking you. Alright, I want to look at interval of increase versus decrease, and what that is referring to is basically up and down. Where does this parabola go up? Where does it start going down? And we're always going to be looking at the x-axis when we determine where does this go up, where does it go down. So if we're just looking at the x-axis, alright, now when we read interval of increase and decrease, it's always from left to right. So imagine this thing, kind of the way it is now, being like a mountain. Where are we climbing up? If I go from left to right, and at a certain point it's going to stop increasing and it's going to start going down. Okay, so I want to kind of figure out where's it going up, where's it going down, and I'm just relating that to the x-axis. Okay, now this is a parabola, so it's obviously going left and right forever. So from negative infinity, so from negative infinity over here, it's going to the left. Positive infinity, it's going to the right. Now we want to figure out where in those two directions, from negative infinity to positive infinity, is it going up and where is it going down. Okay, so from the left, from negative infinity, because this thing does go left forever, we're saying it's going up from negative infinity, and at what point does it stop going up? That would be the interval of increase. Well, it stops going up here at the vertex, at the maximum point, but where does that stop on the x-axis? If you look down here below that point, it's at -2. Okay, so the interval of increase, it's increasing from the left, negative infinity, and it goes up and up and up until it hits the point -2. So if I'm talking about increase, where is it going up? This is how I would notate that. Now you'll notice that on the left I just put a parentheses. On the right I put a bracket, and that's because that -2 is exactly where it stops. Negative infinity is not a specific point, so we put the little parentheses around it. Okay. Now when we talk about decrease, where is this thing going down? Well, it starts going down where it basically stopped going up. So at -2, that's where it stops going up, and it's going to start decreasing from -2, but it's going down to the right forever. If we're talking about right, we're talking about positive infinity. Okay, so when you are labeling interval of increase, interval of decrease, it's either we're talking about left and right, not up and down. So when I say it's where does it start decreasing, don't think that's negative infinity because it goes down. We're talking about our x values. Okay, left or right. Right's always positive, left is always negative if we're talking about the x's, and that's what interval of increase and decrease are referring to. Alright, now we're going to be doing some matching where you have to match a graph to the equation, or you have to match an equation to a graph, and that can be tricky. You could go to a website like Desmos.com and actually check these out and see which ones work. But there are some tricks to narrowing this down. And this graph, it's opening down. Okay, if you ever have a graph that opens down like this, down like we kind of say down makes a frown. If it's negative, it's going to open down. If it's a positive parabola, and then the a term, if the a term is positive, it's going to open up. So in other words, if it was the graph of x squared, it would open up like this. If it was the graph of negative x squared, it's going to open down like this one. Okay, so looking at this specific graph, we can see just right off the bat that it opens down. Anytime we have a graph that follows this little shape here where it opens down, we know it's going to be negative. So looking at these answer choices, I know right away that it's not going to be positive for x squared. Alright, now these other three choices all look pretty good, but let me go to a graph. Let's look at Desmos.com. Alright, this is a graph that you can create on a website. It's called Desmos.com, and you can go here and kind of mess around with the A term, the B term, the C term, and here I'm graphing in standard form. So you got basically what we've been used to seeing, where the A terms in the front, the B terms in the middle, and the C terms at the end. You can see what happens if you change those. If the A term here gets bigger, it creates what we call a stretch. So as the A term gets bigger, it starts to stretch it out, makes it more narrow. As I make it smaller and I start getting closer to 0, you notice it gets wider and wider, and as it becomes fractions, it gets really wide. And the smaller that fraction is, the wider it's going to get. Okay, like that's 0.1. That's what we call a shrink. It's like it's getting flattened out. So that'll help you kind of pick which equation it might be better. It won't give you an exact, just by looking at it, it's hard to tell exactly what it is. But if it's narrow, you could assume that that A term's a bigger number. If it's wider, you could assume it's like a fraction, it's a smaller number. Now if I get into the negatives, it starts making that frown, it flips it. Okay, so I'm flipping it as these become negative, but stretching it as these numbers, the negative numbers get bigger. It's also making that more and more narrow. Okay, now the C term, that's just going to move me up and down. That's going to change my y-intercept. The C term here, if I make it a 4, it just makes the y-intercept 4. Wherever I move this c term, it's going to change the y-intercept. Now the b term kind of moves me left and right, but you'll notice that y-intercept doesn't change. If it's the c term is 4, it's always my y-intercept, no matter what else I do to this equation. I could even start changing the a term. It's not going to change my y-intercept. It's locked in there. Okay. And if you have something on Desmos, you can click on certain points. Like let's say I wanted to find the vertex, okay, and I don't know exactly what the vertex is. These numbers aren't giving me something that's perfect. You can actually click on the vertex and it'll tell you exactly what the vertex is. Or I could click on the x-intercept and it'll tell me exactly what that is, so I can kind of answer questions about it that way. Alright, so let's go back to our graph when we're trying to match it, kind of keeping that in mind. I know it's negative because it opens down, and it looks narrow just looking at it, so I'd say, well, that's probably the a term's probably a bigger number, so I could guess this is the answer and say, oh, you know, I'm pretty confident in that. But if you want to be sure, and I always recommend this, if you're not sure about the answer being exactly right, because it could be negative x squared, right? It could be the first one, I don't know. Just think of this as an input and an output. The x's, just like with linear functions, are going to be inputs. So I can use that equation and I can test it out and see, does it work? Because the equation I'm going to test out, it says y equals negative 4 times x squared. Well, x is a value. All these x values here are numbers that I could plug in. And if that's the true equation, if I plug in a number, like let's say I plug in a 1, I take this x value 1. If I plug that in, looking at that graph, what it should give me here, if 1 is my input, what would I get out of that? Plugging in a 1, 1, 2, 3, and I drop down here, negative 4. I hit the graph at negative 4. When I plugged in a 1 for x, what did I get out of that? Well, my y value was negative 4. That's an input and an output relationship. When 1 was what I plugged in, negative 4 is what I got out of that. I could use the equation and that should still work. Okay, so let's go back to our equation that was 4 times x squared. But instead of x, I'm going to plug in my input x as positive 1. So I'm basically testing out to see if I plug in a 1, does it give me the negative 4 that I get on the graph right here. When I at x equals 1 on the graph, it tells me that the parabola is at positive 4. And if you were to work that out, negative 4 times 1 squared, it does give you negative 4. So I'm pretty certain that this is actually the correct function for this graph because the input 1 gave me. Alright, now I want to look at some word problems and how you would answer them just kind of from vertex form or from standard form. Now here this one is giving you a ball that's been bounced and they give you the equation. Okay, and it helps to understand that in vertex form, what are they giving me? It says what is the maximum height in feet of the ball. Okay, this is negative, and when you're talking about something that's being bounced or thrown or anything like that, the a term is going to be negative because it needs to make this kind of shape. Okay, it needs to bounce and go up in the air, so that's why that's a negative 16 in the front. But they are giving us the vertex, and when they do that, that last number is always going to be the highest point. Okay, so if I'm looking at something that was bounced and it went to a certain height, this last number is always the y value of the vertex. You know, you're going to have your x and your y, and this is going to be the highest point of that, whatever it is. In this case, it's a bouncy ball, but they say that the highest point, the vertex, was at 3/4 and 4. That's the highest point, and y is always how high. If we're talking about the vertex, y is the height, the maximum height, and if it was the other way around, the vertex would be the lowest point. Okay, now there are going to be questions where they ask us to look for basically the lowest or the highest cost for an item. They're giving us this function here, and it says the average cost for a company to produce produce X items, and they give us the function x squared minus 14x plus 45. They say how many items should the company produce to minimize? And that's the key here, is that word minimize. What does that mean? If I'm going to minimize something, well, the parabola, if I were to graph this, look what shape it's going to make. It's a positive A term. It's going to make this shape. When they say minimize, they're talking about the very bottom of this parabola, and they want to know what input, what would I do, how many items would I produce to get the lowest cost, the lowest output per item, the lowest cost. So in other words, what is the X value of the vertex? Okay, so which X value of the vertex is going to give me the lowest Y value? So I'm basically trying to figure out the vertex, but I need to know the X. And the easy way to do that in standard form, to find the vertex, is to use the formula negative b over 2a. Alright, I could put this in Desmos, but the easiest way to do this is to use that formula negative b over 2a. Negative b, well, the b term was already negative, so those two negatives just cancel out, over 2 times the a term 1. That's going to give me positive 7. So 7 is the lowest input. 7 is the amount of items the company would produce to minimize the average cost per item. Okay. All right, so that is how I would figure that out. You could put it on in Desmos and actually graph it. All right, but 7 is the lowest X value that I can plug in. It's going to give me the lowest Y value. Or, I'm sorry, the lowest average cost. Okay. All right, now word problems. You want to look out for what this graph means. The down here in the bottom, the x-axis, when we're talking about parabolas, and if it's a height versus time, like how high was something, like in this case it says how long is the ball in the air, the x-axis is always time, and you'll notice that this actually hits the ground at 3 seconds exactly. So this ball was in the air for 3 seconds, that's how long. And over here on the left, on the y-axis, that's the height of the ball. And notice down here at 0 on the x-axis, this is at the very beginning, it was thrown, this ball was thrown from 14 feet. Right? And if you look at the graph, the ball reached its highest point right up here at 1 second. So I would say the maximum height of this, according to this graph, is 20 feet. It got thrown from 14 feet, it went as high as 20 feet, and it goes all the way down here until it hits the ground, and it took it 3 seconds to actually hit the ground and bottom out. So understand when you're looking at answering questions about time, how long was it in the air? It's always going to be where it hit the ground. That's the, at what time it hit the ground. And the maximum height will always be the vertex at the very top. That's the height, 20 feet. Down here at the bottom, it took it 1 second to reach the maximum height. So any questions about that, just make sure you understand how to read these graphs, which axis is which. The x-axis is always time, it's always your independent variable.